Hello, and welcome to our almost weekly live stream here at Gotham Sound. I'm here with Bryan Dembinski on my left in the studio. Say hi to them.
Hi, everybody.
And Chris Regan virtually on Skype.
Hey, guys.
There he is. Chris, let's start with you. Tell us who you are and what you do.
Sure. I co-founded and am the CEO of RF Venue. We are a manufacturer of wireless audio system accessories, namely antennas, RF distribution equipment, combiners. We do some RF to fiber optic conversion, as well as some spectrum analysis tools for visualizing, monitoring, and managing wireless spectrum, specifically for audio equipment.
Excellent. And you're coming to us from Boston, or outside Boston.
That's right. We're Metro West Boston area.
In Northeast United States for
That's
our
right.
worldwide audience. And Bryan, tell me. I mean, I've known you for many years, but
Yeah, we've known each other over 10 years now. It's crazy to think about.
a decade.
Yeah, I know.
But for those of them that don't know
Yeah,
you,
I started working here in 2004, right out of college. I ran the walkie-talkies back in the day.
That's right.
And now I run TV shows of different ilk. And I also work on some movies and docs. And actually, whatever people want me to do, I do. So
You do features, documentaries,
yeah, features,
reality
documentaries.
shows.
I do mostly like reality and features now, but I do literally almost whatever. So whatever people want, that I design that, I put it together, and I run it.
Related to audio.
Related to audio, yeah.
Awesome. All right.
Yeah.
Well, we're here to talk about antennas. We have a couple of different examples of antennas, and Chris, of course, you manufacture antennas.
Sure.
And you manufacture antennas specifically for film and TV production.
Yeah, for the broader wireless audio category, I would say, outside of film and TV, because, as you guys know, wireless mics are used on TV and film production, just as they're used in, churches, schools, hotels, sort of the broader AV world. We do quite a lot of work there in addition to TV and film. And my background is kind of coming more out of that space, more out of pro audio, so to speak, rather than location TV and film. So I've been learning a lot about what's needed in those kinds of applications, and it's been fun. But I don't have nearly the expertise you guys have in terms of on the ground projects. But yeah, when you think about antennas, specifically for audio systems, one of the considerations, if you look back at the history of RF communications in general, much of it is born out of both the military and over-the-air television and radio broadcast. So a lot of the cues in terms of antenna design and antenna theory come from those industries and those applications, which for the most part require really long range, like over the hills, cover the whole valley kind of range, or are involved with long range point-to-point links where you have two fixed installations, antenna tower up on the hill, and then maybe a downlink to a station in the city or something like that, where you know exactly where both things are. They're not going anywhere, and they're on a fixed frequency. So a lot of that carried over into the design of wireless audio antennas and other RF distribution. And when we kind of got started a few years ago looking at this space, we saw a lot of designs and a lot of approaches that maybe weren't quite as well tailored for the needs of audio systems as they could be. Namely, we don't always need a ton of gain. We don't necessarily always need really long range. And if you play with some of those parameters from the antenna standpoint, you can really have a dramatic impact on how well the audio system performs.
Yeah, I mean, it's interesting because for me, I really started using radio mics, I guess 1990, and they were a single frequency. They were they were Vegas is what I had. Vegas, an old
Sure.
Audio Limited. VHF, these were typically VHF. And I remember when the move to UHF was a big deal. And even then, though, you could get by with, you know, I don't even have an example of it here, but a Yagi antenna. You know, a Yagi antenna sort of looks like this shark fin here, but it's sort of like has a very narrow bandwidth.
Right. And it's big.
And it's big, especially VHF Yagis were sort of enormous. The thing, you can go sailing with the thing if you really sort of made it work. And now, you know, by the way, also in those days, 3 or 4 wireless was like, that was the standard. Now the standard is, I mean, a minimum of 8. People feel more comfortable with 10, depending on the mixer. And then, of course, reality shows, like what you did, you just came off of supervising Ink Master, Brian.
Yeah.
What was, do you remember the number of channels?
It's like 47.
47. Plus the walkies, plus
walkies, plus earwigs.
Yeah, right.
Somewhere in that, yeah.
Yeah, I mean, I remember the coordination we did was like 68 frequencies.
Yeah, well, this season was a little smaller, but yeah, I mean, the most we've done, I think, is high 50s, low 60s. I did a show a long time ago that was like Prodded Runway had like a spin-off Models of the Runway. So we had Prodded Runway and Models of the Runway going, and we had 73 for that show. That was the most I've ever worked on, like done a coordination for. That was pretty insane. That's
insane.
Yeah.
I mean, and of course, and it's like live shows have many more festivals or, you know,
I've heard
Super
over
Bowl.
100.
Yeah. So it gets to be, you know, really complex pretty quickly, even for relatively simple shows. You know, a 4-way multicoupler, I think, was, you know, pretty simple. Now we're dealing with multiple zones, you know, not just a diversity pair.
Yeah.
So, you know, one of the questions I have for you is, talk to me about some of the differences between, you know, my radio mics back in the day had a rubber ducky antenna on them. What are some of the differences between that and an external antenna?
Yeah, so the typical quarter wave, you know, whip antenna that you find that comes stock on a wireless mic manufacturer's receiver will work great. It has a relatively sort of omni field. There are some issues, though, that you can run into because they're attached directly to the receiver itself. They may be in a rack, they may be in a bag. So there's you can kind of quickly get into line of sight issues if you don't have you know, good you know, exposure for those antennas in the field of transmission for the wireless mic. So those work fine. They work very well. In a lot of cases, you can benefit from remoting the antenna or taking those whip antennas off of the receiver or off of the antenna distributor and bringing paddle antennas or spacing those whip antennas or using something like the diversity fin antenna or helicals or whatever the situation may bring. Once you remote the antenna and you have really good line of sight and really good coverage of the area that you would like, you get much greater signal to noise ratio at the receiver and overall better diversity performance than you might otherwise get with just the stock antennas. And in a lot of cases, it's not a major you know, upgrade or a big budget sort of exercise. So it's kind of emerged as a best practice to remote your antennas when you can.
So the first consideration, and you know, we're discussing this, and some of this is pretty basic, but I kind of want to walk everybody through from the beginning the choices that you make.
Sure.
So you know, you have your typical setup, whether you're on a sound card or whether you have, let's say you're in a live situation, you have a bunch of receivers in a rack, you have your whip antennas on the rack, and you're starting to get interference. You've checked that you have clear frequencies, but you notice that your RF level's a little low. So your first consideration for remoting an antenna is, can I put the antenna in a place that has line of sight to my transmit antenna? Is that fair to say?
Yeah, sure. So if you think about, like, a lot of, we like to talk about place and the venue as being a critical component in this, because what will work well in one situation will could work not so well in another situation. So if you're in a venue, or you've got the real estate, so to speak, to remote your antennas closer to where the actors are going to be working, then you get that much greater signal to noise performance at your receiver than you might at a distance or through walls or something like that. So if you think through, if you almost think of like a lighting analogy, if this were a dark room and I wanted to light up the area where my wireless microphones would be working, what would be a good position to do that from?
Mm-hmm. And so I have a lot of choices. These are all examples of different kind of antennas that we can use to hook up. So some of the choices are going to be determined by the frequencies that we want to receive. So for example, this Comtech phase right antenna is typically used for 216 transmission, but wouldn't be appropriate for trying to receive UHF frequencies. And so then the other thing being now with wireless mics, they operate over a much, much broader range of frequencies. And so you need to choose antennas that are capable of receiving across that range, right? So
right.
Here before me, I have, this is an example, this is an active antenna, meaning it has a built-in amplification from Electrosonics. This is passive from PSC. This is an antenna that I'm partial to, which is the PWS, circularly polarized antenna.
I call them the Hemi.
Yeah, the Hemi. And then you guys make, actually, do we have slides for the diversity fin antenna?
We do.
All right, can we show the diversity fin? All right, there it is. Diversity fin antenna, which we should talk about as well. And also here in my hands, the RF Venue Spot.
Spotlight, yeah.
Spotlight. So we've decided we need to choose an antenna for purposes of getting line of sight to increase our signal-to-noise ratio. We've decided that it's UHF frequencies, and we're going to choose a broadband antenna. Can you walk me through some of the differences in these antennas? Like, what's the difference between something that's circularly polarized and a shark fin like this?
Sure.
And your own diversity fin? Yeah,
sure. So the way that antennas work, like with a lot of other equipment, there's a series of trade-offs that you sort of have to think about. One of the core relationships with antennas is beam width versus the gain. So the higher the gain in antennas is in a sense of a matter of directionality. So if you have a really high gain antenna like the Yagi you were mentioning before, or a relatively high gain antenna like the Helical you have there, or the CP beam, or some of PWS's other helicals, those will have a narrower beam width. So if you think sort of left to right coverage, as you go higher in gain, that beam becomes narrower. So which is good in certain situations and maybe problematic in others. So one consideration when you're looking at, say, paddle antennas versus helical antennas versus a diversity fin or a spotlight or whatever, is space, how much room you have to set up, if you're going to be able to fly two of them for a diversity setup. If you're really cramped, two helical antennas can kind of take up a lot of room. Spacing paddle antennas is effective, but also requires two different drops.
How do I know how far to space my paddle antenna? So we're talking about a diversity receiver that's got two RF inputs, and it's choosing the best RF signal from either input. But why can't I just do this?
Yeah, I mean, it's not really going to effectively feed the diversity system if you put the two antennas really closely together. So spatial diversity, 5 feet plus 8 feet, something like that, a couple feet apart is typically enough. In you know, in looking at these different types of antennas, though, aside from the gain and aside from the beam width, they all have different polarizations. And that's one thing that I think does not get talked about quite as much as it should, because it's actually really important, and it has a really dramatic impact on how well the system performs, because it isn't always the case that you lack range because there isn't enough output power on your transmitter, 10 milliwatts versus 30 versus 50. And it's not necessarily an issue where, if we had 3 more dB of gain on the antenna, it would be working better than it is. It's more a matter of how the signal is propagating in whatever environment you're in. So even if you have a really strong signal level, as soon as the transmitter starts moving around, which it is constantly doing, if actors are walking around or there's a chase scene or whatever, that the orientation of that signal just off of the body pack alone is going to be changing on you. And then throw in walls and different reflective surfaces, you can get those that signal oriented in any number of different ways as it moves around. It's actually very complicated to try to really visualize, but in our experience, when you use something like the diversity fin, which is a vertically polarized antenna along with a horizontally polarized antenna 90 degrees from one another, it tends to reduce the number of signal dropouts you get that are caused by that changing angle and orientation of the RF signal.
And that's true not just for the performer's transmitter, but also the RF signal that's bouncing off any interior surfaces.
Sure.
Each bounce changes the polarization as well. Is that right?
In any number of difficult to calculate ways. Yeah. So in most cases, if you're able to use a circularly polarized antenna like a helical, or a polarization diversity antenna like the diversity fin, that will typically improve your outcomes versus signal dropouts that are caused by that effect. The technical term is cross-linear polarization fading, and a lot of work has gone into that for things like cell phones moving down the highway at 60 miles an hour, that are in motion and changing angle. So our thought process was sort of along those lines of okay, well, if the transmitter's moving around a lot and we're in all these different environments, how do you maximize from a probability standpoint that even if the talent takes the microphone from vertical right to horizontal, that you're always going to have some coverage on both of those axes.
And that's why I really love your diversity fin antenna, because it has both horizontal and vertically polarized elements in one space, in one physical space.
If you show that slide, there's a vast oversimplification visual of how
it's up now
of how that works. That'll give you a little bit of a sense where the changing angle of the signal is picked up by that antenna. Now, there's I think another graphic I sent along with the CP beam, which shows a little bit about how a helical works, where instead of just a fixed vertical or horizontal polarization, you've got this corkscrew-like circular polarization, which will have a similar effect to compensate for dropouts that are caused by those angles of orientation changing.
And two notes I'd like to make. We've had great luck with circularly polarized antennas on cooking shows, like in the kitchens with all the stainless steel appliances, where everything's bouncing all around.
Okay.
And then they make a hell of a great IFB transmit antenna.
Yeah, they are particularly effective in transmit applications where you're trying to do the opposite, right? Where you've got a fixed location that you're transmitting from, say for like an in-ear monitor, but you've got a moving receiver. So the angle of the receiver is changing around. So instead of just having a fixed vertically polarized transmit signal like on an IEM with a paddle antenna, if that receiver starts to tilt or change its orientation in relation to that fixed vertically polarized signal, that in-ear system will drop out. That's why you see helical antennas used very widely for in-ear monitors. and for production communication systems.
All right. Well, so I'm starting to we're starting to gather a picture of why you choose one antenna over another. And what are some of the challenges? Like, why not just always have a 1/4 watt, assuming you're licensed to do so, a 1/4 watt body pack transmitter, and why not have at all times an active antenna or like an amplifier next to the antenna? Why not just turn everything up to 11? What's wrong with that?
These ones go to 11. Yeah, sure. So we run into this quite a lot in installed systems where. It'll be a school doing, a theater production or something, and someone installed the wireless system, and they've got the transmitters set on max, and then they've got a helical antenna or something else with a really high gain inline amplifier running through a short cable into a bank of receivers, and the whole thing is just being overloaded. So you can put too much RF into a wireless mic receiver with fairly disastrous results, because if you overload the front end, you are not going to get the required performance to get your audio where it needs to be. So I sort of go back to the spotlight analogy, like the lighting analogy, where if you only need a certain amount of light to cover a certain area, it doesn't make sense to completely light the place up in the highest intensity spotlights that you have. The other drawback of doing a lot of high gain design for receive applications is you're going to pull in all sorts of other sources that can potentially crowd you out. So you'll have higher DTV signal levels in your RF. You'll have more of whatever the guy next door or in the next sound stage is doing in your system to deal with. Whereas if you use something that is more localized, like an RF spotlight or even just passive antennas, regardless of what they are, what type they are, you can get very adequate signal level relative to the noise floor. Because as soon as you start adding, just like in audio and in other areas, once you start adding a lot of amplifiers, you raise that noise floor, and effectively you may not get as much headroom as you think you're getting.
Right, and so Bryan, you have examples of that, right?
Oh yeah, I mean, I prefer a similar thing. I would prefer to not have anything active unless you need it to be active. So like whenever I'm installing a system, I have a bunch of active fins, and sometimes I use those too, like at a low setting. But I would prefer something passive, like these, or a passive shark fin, or even a simple dipole, over just immediately going to like, 12 dB gain on an active fin and putting it on a 25-foot cable. I really don't think that helps you at all. Like, much like when you're talking like, oh, I want to maximize my audio signal on my digital recorder, and so you're always hitting the limiter at like -2, minus whatever. That doesn't give you a great sound. And when you start pumping gain through antennas on short cables and you're just hammering it with RF signals, you end up having much worse range than you would if you just had like, even your whip may be still on it.
Right, because instead of going into limiting, they just saturate.
Yeah, it just gets crushed and you get nothing.
Right.
Yeah.
And
I have one small question.
Yeah.
Does the diversity fin, does that 2 BNC connections then that come off of that? And how does that run? Is that 2 cables? Or you have some sort of specialized cable that makes it back? So I have one.
You have 2 separate BNC connections that you make underneath the cover of the antenna. I should just grab one of these actually. So you make your A and B connection from your distribution onto the diversity fin, and one element is, like I said, vertically polarized, and the other is horizontally polarized. So they're not really in any kind of relation to one another.
Right.
So as the RF is coming in off of the directional antenna, if you're getting a lower signal level there, the system, the diversity receiver will switch over and back accordingly.
Right, that makes sense.
You can sort of see this a little bit here. It's a black one, and it's kind of dark in here, but yeah, both of
okay, I
your
gotcha.
2 BNCs
are made there.
Okay.
Yeah, cool.
Interesting.
And I want to talk about the RF Spotlight before I see Jonathan Redhorn. I see your question, and we'll get to that in a second as well. But that's also the beauty of the logic behind the spotlight antenna, which is the idea is that it's, if you looked strictly at the sensitivity spec of that antenna, it would be less sensitive than some of these antennas, less gain. But that's its point also.
Yeah, I used this once.
Yeah.
Yeah, and we were shooting on like, we were on the top of a building in New York City, and I went and I did the scout, and it was like RF nightmare. So all I really needed to make sure is almost all the lines were just said by our host, our main talent. So I had the art department, you know, put something, I don't remember what it was, some Formica or something, stuck this under it, ran a cable out, ran it just to his receiver. I had decent RF, and then when he went and stood on his spot and started talking, I had full signal. And it was great. It was really simple, really easy. It was easy to hide. Didn't really matter like if the jib was going or what was happening. I knew I always had him because he was literally standing on the antenna.
Yeah, if you're not filming like a chase scene or something, and you're just going to be operating in a limited area, yeah, I mean it works great. I mean they park them under the like anchor desks and like on the voice where all the judges sit. I mean they're not going anywhere, so it doesn't make sense to you know put too much of a high gain antenna in there. But the part of what you just mentioned, you know, that benefits from using that kind of approach is the proximity effect. So the location and distance between the transmitter and the receive antenna has enormous implications on your signal to noise. So how much, you know, good quality signal you get relative to everything else that's around you. And the spotlight is particularly effective at that because it's designed to go on the ground. So since it's not up in the air, it's not, you know, designed for long range or maximum gain, it's going to do a really nice job of pulling in the signals that you have within that, you know, 100, 200 foot diameter where it's positioned. But it does a terrible job of picking up things that are at a distance on the horizon, like DTV stations, just because of that angle of incidence. So you have a like a half globe, you know, hemispherical pickup pattern around where you position that spotlight, where in a fixed situation where the talent's not going to be moving around a lot, and you're in a crowded RF environment. Like we did I think a video and a test on this in Central Park where it's pretty telling. You can dramatically attenuate everything else that's going on around you.
Makes a lot of sense.
Yep. So I also think we ought to talk about, when we talk about active antennas and passive antennas, the formal way that this is done is what's called a link budget. Is that right?
Sure.
Where you sort of start out with how much power you have at the transmitter, how much loss there is from the transmitter to the antenna, and then each thing in line sort of has a gain or an attenuation after that. So there's so much loss per 100 feet through the air. It hits an antenna. The antenna has some gain. And then there's also loss through the coax cable from the antenna to the receiver. And then if you're splitting the signal from there, if that doesn't have a little amplifier built into it, there's loss with the splitter.
Every barrel connection.
Yeah, and every barrel connection you lose half a dB.
Including the ones that you like on your passive splitters.
Yep. And so it all adds up or sometimes subtracts down.
Yeah.
And that's really, for me, that was the most telling moment when I was thinking about antennas, even on a simple sound card situation where you don't want to blast the RF signal into the receiver. You sort of want to, if you are going to use an active antenna, the decision should be made based on what the loss is through the coax between the antenna and the receiver. You're sort of trying to keep unity gain in a way.
It's like a signal flow chart. It's just an RF flow chart. It's like should be the similar thought pattern. Like, when you have your signal flow, you have your microphone goes through your cable into your mixer, out of your mixer into your recorder, out of your recorder to your IFB or your speaker. I mean, it's the same basic idea. We're just talking about RF energy rather than sound energy.
Right, and then finally you end up with the amount of anticipated signal at your receiver, and that's either going to be enough signal or not enough signal depending on the receiver's specifications. All right, so wow, Jonathan, we have Jonathan Redhorn. How would you place IEM antenna and wireless receiver antenna if they are both located at the monitor beach, is what he says. Can they be near each other? Am I going to run into issues with that? So that's an interesting thing. And that happens both in live sound and in sound carts, where you have, you know, transmit antennas for IFB, and then you have receive antennas for talent. Yeah, I mean, for me, and you guys chime in, please. You know, for me, I want a minimum separation of distance. One trick that I learned is that oftentimes it's more effective to separate antennas vertically, yeah, rather than horizontally, that you get a little bit of extra isolation by doing that. And then finally, separating and filtering frequencies. So you don't ever want your transmit antenna to be in a band that you're being used on your receive side. Yeah. I mean, ideally you'd want something like at least 20 megahertz apart. Yeah, that's like so one thing to do with, like, a lot of people use these electro venues things now. Yeah. So I really like the old venues, but the new ones are all wideband, so they're like 19 to 26, give or take. Mm-hmm. And if you have like, you have 6 receivers in there. If you have 6 different blocks in there, okay, fine. But you probably should put 1 block or maybe 2 blocks that are right next to each other. And then Electro and other companies sell filtered ends. So you have 1920 in your venue, and then, you know, you have your antenna, and it goes in, and then it goes into a filter, and then out of the filter it goes into the venue, because you don't need all the extra noise in your RF track. You want to make it as simple as possible. Right. And also with your IFB transmitters versus your receive, the same thing. You want to be at least 2 blocks away, in my opinion. Yeah. I would even sometimes do more. And then you also don't want to pump your IFB. You don't want to put like 250 milliwatt IFB out when you have 100 or 50 watt transmitters everywhere. You're just going to blow your antenna out, and you're never going to get anything good. I would actually like suggest, you know, you put your IFB at 50, and actually that's mostly what I do now, is put your IFBs low, and then it helps you get above everything else in the world. And if you need to, you're like, oh, my IFB is at a little short range right now. All right, hold on, I'll help you out. And put it up, you know, 50 milliwatts, and now you're fine. Right. You know, start low and then work your way up. When people start pumping things high, there's nowhere to go. You're stuck. So as low as you can start, the better. And then as you go, give yourself more room if you need it. Right. Interesting. Chris, do you have anything do you want to add to that?
Not really, no. I mean, you see something very similar in live music production with in-ear monitors and wireless microphones. Guys will put the IEMs in the 600s and put the mics in the 500s and try to separate things out accordingly. If yeah, I mean, that's all on point, sure.
Yeah. All right, so we have a couple of other comments and questions. Previously, I've had mic receivers at front of house, but have had video interference issues. Going to move mic receivers off stage, but don't want to run into issues with IEM. Right. Planning on using combiners and distributors, having antenna located outside of rack. All right. Well, for one thing, there's the live sound people have to deal with RF sources that we cart people generally don't. And I know, you know, the video walls are a huge source of interference for them. That's, you know, that's sort of an interesting thing too, and it reminds me that, you know, with directional antennas, it's not always advantageous to kind of point it at the actor up high, because sometimes you end up pointing it at what's behind. In fact, often you end up pointing it at what's behind the actor, which could be, you know, in New York City's case, the Empire State Building, or the, you know, what is it, 7 Times Square is the transmit tower. And so a lot of times, you know, sort of using the directionality of the antennas helps out a lot. Sort of like coming at it from the side in much the same way that you might use a shotgun microphone.
Yeah. So this is where you know, you start to look at, well, you know, what's a good position, what's a good angle, and you can make a lot of great educated guesses. Yeah. But this is where spectrum analysis is really key. So the ability to visualize and see what's going on, and what happens when the antenna is moved from here to there, and which is more advantageous for you. That's something that I think should be, you know, just part of sort of basic setup. It's not really now. A lot of time is spent on coordination and getting frequencies that will be free from intermod, but you don't necessarily take into account a lot of the sources that might be third party from you, whether it's a video wall, whether it's some other rented equipment that's in there that you don't have any control over. So if you can tap into your RF from your paddle antenna on location and get a look at what's around you, you can much more effectively determine what the best position is for your antennas, so that you can potentially orient something like a paddle antenna with your interference sources to the rear, because it will have less pickup behind the antenna. So if you have some kind of third-party interference like a video wall, you want to make sure that you don't have that in the line of sight of your antenna if you can help it. But all of that is really enabled by visualizing the entire band.
Yeah, and you guys have products that answer that.
There's lots of we make a rack-based spectrum analysis product. There's the handheld RF explorers are handy just to get a view of what's going on, and it goes all the way up to, we use Agilent RF spectrum analyzers here that are 10 or 12 grand, that are probably overkill for a lot of location sound. But yeah, I mean, just having a view, even if it's just something a little better than just what the maybe the venue spectrum analyzer is giving you, can be really helpful.
Yes.
Yeah.
Agreed.
Sometimes there's no time necessarily, a lot of times in location sound to do that, but you're right, like when I install something, I don't know if I run it through like a full spectrum like you do, but I do use like an RF Explorer type product, and I get a full view of what everything's really looking like, and I try to like piece together some sort of plan about, as I start firing everything up, how is my signal looking, and then I take one more quick look with everything hot and going through, and like how is it looking on the venue, and how is it looking in the analyzer. And actually, like when I'm using those 50 mics now, I like at least half of them to be on 50 milliwatt, and I have none of them on 250. Like never do I put anything above 100 anymore, unless it's some sort of desperate times.
Right, and in the case of Inkmaster, what did we determine that was? That's 12,000 square feet?
It's huge. It's like 12,000. Yeah, it's like 3 stages across multiple floors,
right,
plus interview rooms.
Yeah,
yeah, it's huge.
And so using less RF actually gets you more range.
Yeah, I think it's impossible otherwise. Well, no, it's not true. You'd have to go through like 6 or 7 blocks of frequencies, like electro-style blocks, or use up a huge wideband system,
sure,
in order to get that many mics at that high of a gain. But if you put things at 50 or 100 for like the contestants, and 50 for everybody who's not a contestant or a judge,
right,
it's not as bad as you would think.
Good.
It's actually very doable.
That's good to know. And in the future, we're going to see digitally controlled RF filters, and I mean, I see all sorts of new products on the horizon that sort of speak to a wideband world, where if you're trying to do band planning, which is I guess the formal term for that, you're going to be able to have selectable, controllable filters that can move around as your frequency needs change. Which is
that's going to be the key. I think that's going to be the thing. The less RF that you bring into your receiver, like the less things you don't want. Like if you want 650 megahertz, come in, anything you can filter out outside of that before you bring it to your receiver is going to help.
Yeah. The
more the merrier.
Yeah. So basically, one of the reasons that we got started in this space was we saw a lot of that happening. So how do you do more with less spectrum? And as the needs kind of grow for wireless audio, as you mentioned earlier, the channel count's just getting higher and higher. The amount of usable spectrum is going to be less and less. So you're right. Filtration is going to be a part of that. That's definitely something that we're working on. But the other thing is you can already do a lot of that by using some of the local field antenna techniques that we were talking about earlier, where say the less RF you get in, you're essentially doing that filtering just at the physical layer. So instead of manipulating the RF signal once it's inside a box on its way to your receivers, you've already pulled in relatively or clearer RF than you would otherwise, and then need to filter out for.
No, it's true.
This is great. This is awesome.
All right.
I feel like you know, we should wrap it up. It's been 50 minutes. Where I don't want to bore everybody. Chris, is there anything you want to add?
I will shamelessly plug our blog. Alex Milne runs Audio Gloss that has so much information about. I just got a chat from Alex that he's got links left and right to everything we're talking about with great visuals and diagrams and stuff like that. So if you want to learn more about this stuff, head over to blog.rfvenue.com and you can read about spectrum policy and antenna techniques and all this other stuff. There's
no shame in plugging. It's an awesome, amazing blog. Alex does an amazing job in that. It's great, and I recommend everybody go check it out right now if you don't know it. And Bryan, anything you want to add before we move on to the next topic?
No, I'm good. All right. I mean, I can talk about antenna, other stuff too if you want, but I'm all good. Whatever you want to talk about.
I feel like, you know, like bringing it in under an hour is
it's good,
a goal.
Yeah, I think we killed it.
And Chris, you're welcome to stay. There's a new product that's sort of like coming out now that has nothing to do with RF, but is exciting for me personally. It's made by a company called Apsis, and I should grab the graphics here. Bear with me for 1 second. Oh, wait, do you have them preloaded, Jared?
Nope.
Oh.
Hey, Paul, on a side note, do you use this PIX thing later for something? Because it's about to run out of hard drive space. Okay.
All right. Bear with me for 1 second. I am totally not prepared for this. All right. So it is called the Apsis Multirotor. And basically, you know, what we've been doing is, you know, in our world, we've been going through Dante. And we've been sort of noticing that there are still some legacy products we'd like to talk to and add to the Dante network. And there's some new products coming out now. And what the Multirotor does is it will take MADI, Dante, and then interestingly, AES 67, AES 50, and ADAT, and sort of bring them, allow you to convert them all to one or the other, and the other. It's basically a matrix. What I find exciting about this, and it'll sync to anything that you feed it, and it'll sample rate convert the rest, including you can feed it word clock, and then it'll sample rate convert everything to the word clock that you feed it, and it also will allow, for example, a Yamaha mixing console to be able to control the remote preamps and phantom power and filters on the Behringer S16 preamps, remote preamps, which is a very, very interesting idea, I think. So keep your eyes out. I know there are links on our website for Apsis Multirotor. And yeah, it's shipping, he said, end of October, he being Rolf of Apsis Pro Audio is the name of the company. appsys.ch. All right, so we have some more questions, which is, I'm glad you're with us, Chris. I'm just going to bring you back to full screen, I hope, or nope, I am, wait. Bear with me for 1 second. There you are.
Somebody wants to talk about zones.
Yeah, here we go. Okay, Josh Neal, can you talk a little bit about antenna zones and how you would set those up?
A little bit. It's either a long bit or
yeah. All right. Well, never mind about the hour show. Under an hour. No, I think you know. So, look, things are easy when everything is in one room, right? And so on a show like Ink Master. Where you have one...
Just think about the idea. I don't think it matters what show you're on, so I don't think that helps so much. But the only reason you want to do zones is you want to think about stages, right? So if you have multiple stages of action, that's when you start zoning. If you have one stage, it's really, it's going to be hard to do a bunch of zones because you're just going to start, much like phase cancellation in audio, you're going to start having phase cancellation in your antennas.
That's right.
Especially if you do a bunch of powered antennas.
So
you can sort of pull it off if you have passive antennas and you have a huge space, but really as soon as you start gaining up antennas, you have one A antenna, one B antenna per stage, and then each stage becomes your zones.
And when I do zones, I like to think of the isolation from each antenna and space them out accordingly. So,
yeah,
for example, I'll never put two A antennas. And when we say A and B, we mean the diversity inputs on the receiver.
Yeah.
I'll never put two A's next to each other.
No, you'll have a disaster area if you do that. So like, if you think of like your stage is a big rectangle, you like have an A antenna here, you maybe have a B antenna here, and let's say this is like some weird dead area, you could put like another A there, maybe, but you have to be really careful about how you're putting it in there, and whether or not it's active or passive.
And that might be an excuse or a reason to use a lower sensitivity antenna.
Exactly.
So that it has the most amount of isolation possible.
Yes, exactly. Passive antenna, really close, or maybe even something like this sort of style of product underneath that part, so it's like very specific for that one area.
And products, PWS, Professional Wireless, makes a great combiner, like their DB8. And what's interesting is each input has an attenuator, so you could really dial in the amount of isolation that you want off of each antenna.
I can't find I don't think it does anything on passives, though. I've played around with it a lot. I don't see it do anything. Only when you're active does it do anything.
Oh, really?
Well, maybe they'll tell me.
I can't figure it out. Ask them.
Yeah.
But Chris, is there anything that we've said that you want to add to, or is not quite accurate?
No. I might just add a common two-zone setup. We like I said, we get involved with broader kind of AV wireless mic installations, and a lot of that is like breakout rooms, or in I suppose in a TV film production analogy, it might be two sound stages right next to each other. Okay, room one, and room two. You can create a relatively simple two-zone setup by taking 4 antennas, so 2 A's and 2 B's, positioning those in room 1, 2 in room 1, 2 in room 2, and then bring down the A connections from room 1, combine those together passively with a little just 2x1 splitter combiner, and bring down the 2 B antennas together with the same type of passive splitter combiner, and then you've got a single A and a single B, and then as the microphones move around between those two zones, the diversity system, based on the proximity of the transmitters to the antennas, will do some of that work for you. So if you're looking for relatively simple, low cost, that can be a nice way to go.
That's right, and it's important to remember that those combiners have loss associated with them too.
Yeah.
And that's part of that link budget that we talked about earlier.
I guess that's true.
It would depend on like how long the cable runs are. I mean, if they're super long, you're going to want to put in inline amplification to try to overcome some of that. So it's certainly not for every single application. But if you can get good proximity between the transmitters in Studio One and the receive antennas in Studio One, and likewise in Studio Two, even with some of that loss over the cable and a little bit of loss at the splitter, you may still have a good amount of signal to work with, although it might not be the theoretical 0 dBm ideal of the perfect link budget. Which
is okay as long as you're sort of above the sensitivity sign out of the receiver.
If it works, it's good.
That's right.
Yeah, that's true. As long as it's working, you're okay.
We have Corey Allen is saying, if you don't have a spectrum analyzer, are there any resources for knowing which bands are clear in different cities?
Probably not. Somebody should invent something like that.
Well, there's any number of places. GothamFaxes.com is a resource that has allows people to send in scans. Sennheiser Sennheiser has a site where you can punch in a zip code and it'll give you what the FCC database says. Shure, I think, also has.
What about James's app? Does it sort of have that some preloaded? Or
I think it's, and James Lafarge's app, which is called Freak Finder, will draw from the FCC database. You know, yeah, I think the nice thing about lower cost spectrum analyzers is that everybody should have one. I mean, I think whether it's the handheld RF Explorer or the rack mount version that you got, the RF Explorer Pro, I think if your living depends on wireless microphones or wireless communications, you should have a tool that lets you see what you can't see with your eyes, which is the RF spectrum. Alex Milne said it should be said that the helical on the table.
No, it says PA.
Oh, is the Sennheiser not a PWS? If
no, that's the PWS.
That's the PWS. Yeah.
Yeah, it says on the back professionalwireless.com.
Yeah. It's close. They look similar and they work the same, and it's the same idea. Yeah. But that's right. Yeah, I
love these things.
Yeah,
these are my favorite.
They're
Although I'd love to try the diversity fin. You
should try the diversity fin. You know, the thing that ought to be said again about the diversity fin is that if you're limited in space, that is hands down I mean, as far as I'm concerned, the only choice you have.
Also, it's easy. That's the thing. You want if let's say you're doing like you have a sound cart and you have to move a lot, and you don't want to have one of them, you know, big speaker bars in there. Even if one's at full, they're still quite large. They blow in the wind and all that jazz. You can literally, you know, take a C-stand, put it wherever you need to go.
We've seen some location sound guys rig them to bags and rig them to cars and rig them to, you know, different setups, whether they're moving around or they're in a fixed cart. So yeah, once you just have a single point of install, sometimes things get a little bit easier, or at least give you some more options.
Yeah, I think that's right. Matt Sonnenfeld writes in, I've been having a lot of success using RF Venue Diversity Fin with Wizicom MCR42 receivers in the SL6, which is Sound Devices version of multi-coupler.
Okay.
Yeah.
That makes sense.
Been keeping my transmitter now at 10 milliwatts unless an extreme situation.
That's impressive.
That's super impressive. Yeah, that's great. Yeah.
The other side effect of that is battery life. So if you're not, you know, doing 50 milliwatts, you're going to have to change batteries a lot less, which, you know, obviously is good.
It's great. It's true.
I think actually the mode should almost be the European style, where we should go back. We should like stop this idea of like more power, and there should be less power in exactly the right place. Because I was really noticing that in on the last job is that like spectrum crazy. Like it's just so much stuff everywhere, and unless like I feel like narrow band stuff is so hard to use, a whole ton of it. You need these like a lot of companies are doing these wide band RF now, but you're gonna have to do that, and then you're just gonna have to find the little openings, and you just use, you know, just that's how you place it now. Place it within the small openings rather than trying to overpower the small amounts of signal that are around. Yeah. Because there's so much signal, and it's strong.
It's gonna get worse.
It's gonna get worse.
3 years. Yeah.
You know, everybody has one cell phone. Everybody's gonna have even more powerful LTE, whatever, next generation this, and it's just going to blow us out.
Well, I believe the whole white space device thing, all right, this is my soapbox. I believe the whole white space device thing is really about cellular carriers being able to offload excess capacity off their cellular networks and onto you know, white spaces.
You think so?
Yeah. I think that if there's all of these sort of white space devices available to a handheld device, when you call somebody, it's going to be able to seamlessly switch back and forth between the cellular network and the data network.
But also, you know, like the cars now have their own built-in Wi-Fi networks, and they're going to start sucking up all this space too. Like if you have these self-driving cars, they're going to have to communicate with something somehow.
God. Yeah.
Right?
All right. Well, we've derailed the train.
Sorry.
And Chris, thank you very, very much. This has been awesome.
Sure. No, this was fun. I appreciate you invited me to join. Thanks.
Thanks for coming. All right.
Amazing.
Take care. Next week, we are talking to Glenn Sanders from ZaxCom. He will be live in person. And of course, vimeo.com/GothamSound is where you will see all of the archive presentations and live streams. And as always, your ideas are welcome at info@gothamsound.com. Chris, thank you. Brian, thank you.
Of course.
Have a great rest of your week.